So this video is going to look at some of the homework problems that you have on graphing absolute value functions. And we're going to use the rules that I did in the last video as well as a table of values to get the graph of all of these absolute value functions onto a coordinate grid. So let's start off by just recapping those rules. So if I have some absolute value function and I'm multiplying it by something, and maybe I'm adding or subtracting something, and then I'm adding or subtracting another number on the outside. This number here, the A, is in charge of stretches and shrinks. Stretch or shrink vertically. So vertical stretches or shrinks. And if A is positive, then my graph opens up. And if A is negative, my graph is flipped. It opens down. It's upside down. So that's the number outside the absolute value bars. The number inside the absolute value bars, which I have written here as a B, is in charge of moving the graph left and right. So the B moves the graph left and right. And if the B is negative, or if we're subtracting B, we're moving the graph to the right. And if we're adding B, we're moving the graph to the left. So it's the opposite of what you think. And then the last number that changes the position of our graph is the C, the number we're adding or subtracting at the very end of the equation. The C is in charge of moving our graph up and down. So the C moves the absolute value graph up or down. And if you're adding, it moves the graph up, and if you're subtracting, it moves the graph down. So we'll be able to tell pretty much right away, just by looking at the graph or at the equation, where the graph is going to end up, and we'll use the table of values to decide very specifically where it's going to end up. Let's take a look at the first graph here. The first equation, f of x equals absolute value of x minus 4. So I'm subtracting, and I'm subtracting from the x inside the absolute value bars. So I know that it's going to be moving my graph either left or right, and because I'm subtracting, I know it's going to be moving the graph to the right 4 units. So it's going to move from the origin over 1, 2, 3, 4 units. And then I'll use the table of values to figure out where the rest of the points are. And they've given me some x values to use, so I'll plug each of those into my function. X is negative 4, so negative 4 minus 4 is negative 8, and the absolute value of negative 8 is positive 8. When x is negative 2 minus 4 is negative 6, and the absolute value of negative 6 is 6. 0 minus 4 is negative 4. Negative 4, the absolute value of that is positive 4. 2 minus 4 is negative 2. The absolute value of negative 2 is positive 2. And 4 we already have. 4 minus 4 is 0, and the absolute value of 0 is 0. So let's fill in the rest of these points on our coordinate grid. Negative 4, 8. Negative 2, 6. 0, 4. 2, 2. And I already have the 4, 0. This is 1/2 of my V. Remember, I'm making a shape that looks like this. Just like a parabola, there's an axis of symmetry that runs right down the middle of my graph. And I can use that axis of symmetry to reflect each of the points that I got from my table and get another set of points without having to do a whole lot of of arithmetic. So the 2, 2 point I can reflect over my vertical axis and end up with 6, 2. The 0, 4 I can reflect over and end up with 8, 4. The negative 2, 6 I can reflect over and end up with 10, 6. And I think I'll stop there. That gives me a good sense of the shape, which I know is going to be a V. And there it is. And indeed, it has shifted over 4 units to the right, just like we predicted it would, reading the equation at the beginning. Let's try another one. G of x equals the absolute value of x plus 4. And here again, I'm adding inside the absolute value bar, so I know I'm going to be shifting the graph to the left or to the right. Because I'm adding 4, I'm going to shift the graph to the left 4 units. So I know my graph is going to be over here to the left. Let's use the table of values now to get some more points. So once again, I'm plugging the values from the table into the function that they're giving me. So negative 4 plus 4, that's 0. Negative 2 plus 4 is 2. 0 plus 4 is 4. 2 plus 4 is 6. I think I can do the last one in my head. 4 plus 4 is 8. Let's graph those points. Negative 4, 0, negative 2, 2, 0, 4, 2, 6, and 4, 8. And just like the last graph, I've got an axis of symmetry running down the middle of my graph that I can reflect the points from my table over and get a whole other bunch of points. So I'm going to do that now. And I'll connect them and take a look at my V-shaped graph, and indeed it is. It has shifted to the left 4. Let's do another one. F of x equals the absolute value of x minus 4. So now I'm subtracting 4 outside the brackets, outside the absolute value bars. This means that I am moving the graph up or down. Because I'm subtracting 4, the whole graph is going to move down 4. So 1, 2, 3, 4. There's where my graph is going to end up. Now I'll go ahead and fill in my table. So the absolute value of 4 is 4. 4 take away 4 is 0. The absolute value of 2 is 2. 2 take away 4 is negative 2. The absolute value of 0 is 0. 0 take away 4 is negative 4. The absolute value of 2 is 2. 2 take away 4 is negative 2. And the absolute value of 4 is 4. Take away 4 is 0 again. Go ahead and plot those points. And in this case, I have enough points in my table to give me the shape of the graph. I know it's going to be a V, and I can definitely see where it is. And I can see that my graph does match what I predicted. It has shifted down 4 points from the origin. My second graph, g of x, or my fourth graph, g of x equals the absolute value of x plus 4. I'm adding outside the absolute value bars, which means it's going to be a shift up or down. Because it's positive, it's going to be a shift up 4 points. Go ahead and fill in this table of values. Negative 4 is 8. Negative 2 absolute value of that is 2. Plus 4 is 6. Absolute value of 0 is 0. Plus 4 is 4. Absolute value of 2 is 2. Plus 4 is 6. Absolute value of 4 is 4. Plus 4 is 8. I'll go ahead and graph those points. And once again, I have a good sense of the shape of that V, so I'm not going to have to worry about reflecting any points. And when I look at the final graph, it has shifted up 4, just like the equation predicted that it would. Let's do a couple more here. F of x equals 2 times the absolute value of x. G of x equals 1/2 times the absolute value of x. And h of x is negative 2 times the absolute value of x. So when I'm multiplying outside the absolute value bar, this is going to be either an opening or a closing because I'm stretching the vertical axis. When I multiply by 2, it's going to close it up a little bit. When I multiply by 1/2, it's going to open it up a little bit. And the third case, I'm multiplying by a negative 2, it's going to close it up and it's going to flip it upside down. So this graph here is going to be closed up and flipped upside down. So I'm not adding or subtracting anything either inside the absolute value or adding or subtracting outside the absolute value bar. So I know that it's not shifted left to right or up and down, but it is going to be flipped upside down. Let's fill in the table of values and figure out where those points should go. So negative 4. Negative 4, the absolute value of that is 4 times negative 2 is negative 8. Absolute value of negative 2 is 2 times negative 2 is negative 4. Absolute value of 0 is 0 times negative 2 is 0. Absolute value of 2 is 2 times negative 2 is negative 4. And the last one. Absolute value of 4 is 4 times negative 2 is negative 8. Go ahead and plot those points. And you can see for sure it's upside down. Maybe if I zoom out here, we can compare that to an earlier graph. Zoom out. So hard to see. It's hard to see, but a little bit you can see it's closed up a bit if I zoom back in and graph the parent graph. So if I graph just y equals the absolute value of x, and I'll make it the negative absolute value. So it's also flipped. Whoa, come back here. Also the absolute value of x, but upside down. They'll start off the same here. But what will happen is I end up with a graph that looks more like this. So you can see by multiplying the absolute value by negative 2, this piece right here, I'm definitely closing the graph up. All right, last one here. Now I've got a combination of things happening. In my first graph, f of x, I'm multiplying by a negative 2, so I know it's going to be flipped upside down and closed. So the negative 2 means that it's upside down, and closed. And adding 5, so adding 5 means I'm shifting it up 5 units. Go ahead and graph the up 5 units first. I know my graph is eventually going to look like this, but it's going to start at 5, and we'll fill in the table of values to get the rest of the points. So negative 2 times the absolute value of negative 4 plus 5. Absolute value of negative 4 is 4, times 2 is negative 8, plus 5 is negative 3. Absolute value of negative 2 is 2, times negative 2 is negative 4, plus 5 is 1. Absolute value of 0 is 0, times negative 2 is still 0, plus 5 is 5. Absolute value of 2 is 2, times negative 2 is negative 4, plus 5 is 1. And I'm running out of space here. Absolute value of 4 is 4, times negative 2 is negative 8, plus 5 is a negative 3 again. So go ahead and graph those points. And connect them. Oops. And there's my upside down graph that's closed a little bit and shifted up 5. All right, let's look at the last one here. 1/2 times the absolute value of x minus 3 minus 1. So we have 3 different transformations that have happened here. This one, the 1/2, 1/2 is going to open the graph. This transformation here, subtracting 3 from the x, means I'm going to shift to the right 3. And the last one, subtracting 1, means that I'm going to be moving the graph down 1 unit. So I know that that point, the vertex of my graph, is going to be moved over 3 points to the right and down 1 unit. So 1, 2, 3, down 1. Now I'll fill in the rest of the table and we'll figure out where the other points are. So all I'm doing here is just substituting the values that they're giving me for x into the table. And then we'll use order of operation to figure out the rest. Now remember, I can't just make the 4 and the 3 positive. I have to use order of operation, combine them first, then take the absolute value. So negative 4 minus 3 is negative 7. The absolute value of 7 is 7. And then I can multiply 7 times 1/2 and subtract 1. So 7 times 1/2 is 3.5. 3.5 minus 1 is 2.5. 2.5. 1/2 times negative 2 minus 3 minus 1. Negative 2 minus 3 is negative 5. Absolute value is positive 5. 1/2 of 5 is 2.5. 2.5 minus 1 is 1.5. 0. X minus 3. So 0 minus 3 is negative 1. Absolute value of negative 1 is 1 times 1/2 is 1/2. Minus 1 is a negative 1/2. And then we're back to 2. And that's just going to reflect it again. So go ahead and write them in 1 and 1/2 and 2.5. Go ahead and plot those points. way down.